Good evening again. This is Mr. Rafapa from Somel PSA Tutoring Academy. We are here now on Northwest Prelim Graphic Cubic Functions 2023. This is what Northwest was faced with. Okay, so they gave us the function and they gave us only stationary points. All right. So if you have a function like this, the first question prove that A is dead and B is dead. So the first thing that I would like to do is f of x equals to, that's what, 3.1. This is 3.1. Ax cubed plus bx squared. Ax cubed plus b x squared. The points that I have is 0 is to 0 and 0 is to 0 and 2 is to negative 1 over 3. 2 is to negative 1 over 3. All right. Okay. So the first thing that I will do is to find the image. Me and you can agree. If I put x as 0, I put 0 here. The right side, all of it is going to be 0. And that other side is going to be 0. So there's no point using this. I can use this. On y, I put negative 1 over 3. And then on x, I put 2 cubed plus b2 squared. So 2 cubed is 8a plus 4b. This is negative 1 over 3. I can say this is my equation 1. Then my equation 2, because I have stationary points, I know that f, the gradient is 0 at x equals to 0 and x equals to 2. So I will do what? I will find the general equation for the gradient by deriving that. So 3 times a is 3a squared plus 2bx. So you and I can agree that I want to put this as 0 at which x? Is it this? If I put, no, there's something that I didn't do well here. This is going to be 3ax squared. Okay, so if I put x as 0, this is going to be 0, this is going to be 0. There's no point using this one. I'll stick to the one of 2. So 3a 2 squared plus 2b2. So 2 squared is 4. 4 times 3 is 12a. And then 2 times 2 is 4. So it's going to be 4b. Then this is 0. So this comes that other side. So this is maybe equation 2. So from equation 2, I can say negative 12a equals to 4b. And then divide by 4 on both sides. Therefore, b equals to negative 3a. So wherever I see, let's say this is 3, I can say substitute 3 into 1. This is like what we call a Smaltina's equation. So from equation 1, this is negative 1 over 3 equals to 8a plus 4b. So wherever I see b, I put minus 3a. So this is going to be 8a plus 4 minus 3a, negative 1 over 3. So therefore, this is 8a. This times this is minus 12a minus 1 over 3. 8 minus 12 is minus 4a minus 1 over 3. So divide by minus 4 on both sides. my a is what? Minus 1 over 3 minus 4 is minus 1 over 12. So my a is positive 1 over 12. Then remember, what is a? What is b? The equation for b equals to minus 3a. Minus 3a. So for b is minus 3, 1 over 12. So my b is 3, is minus 3, 1 over 12. So this is negative 1 over 4. So this is going to be negative 1 over 4. So they said we must prove what? A is negative 1 over 12, B is negative 1 over 4. A is positive 1 over 12. So I'm done. I'm done doing that. Therefore, that means my total formula is going to be 1 over 12 x cubed minus 1 over 4 x squared. So that becomes my equation. Where is this concave down? I need the point of inflection. So this is my x is 0 here, and here x is 2. So I need the point of inflection. So I will take the x values of the turning point, which I already have, which is 0 and 2. Point of inflection. So that is 3.2. Point of inflection. The x value of the point of inflection is 0 plus 2 over 2, which is 1. So that is 1. You can do that method of deriving twice. So that is 1. So x equals to 1. So this side is concave down. That side is concave up. So they want what? 1 of down. So it's x less than 1. So this is x less than 1. It's concave down. We're done with that one. And therefore, they say determine the equation of the tangent of f at this point. So for me to find the equation of the tangent, I need remember the equation of the tangent is what? Is a straight line equation. Straight line equation must have, to find the straight line equation, you need a point and you need a gradient. Okay, so I first need to find the y value of when x is equals to negative 2. So that is 3.3. So when x equals to minus 2, so that is 1 over 12 minus 2 cubed minus 1 over 4 minus 2 squared. So I need to find the y value of that. All right. So here we go. It's going to be 1 over 12 times minus 2 cubed, all right, minus 1 over 4 minus 2 squared. So that is minus 5 over 3. So that is minus 5 over 3. All right. So that is minus 5 over 3. So the point, you need a point, remember? The point is negative 2, negative 5 over 3. Now you need the gradient. The gradient is what? F prime x. So this times this, 3 times 1 over 12. So 1 over 12 multiplied by 3 is 1 over 4. So when I derive that, it's going to be 1 over 4 x squared. Therefore, this times this is going to be a half, negative half x, negative 1 over 2x. So this is the general gradient formula, but I need specifically the gradient at minus 2. So 1 over 4 minus 2 squared minus 1 over 2 minus 2. Okay, so this is going to be 1 over 4 multiply by minus 2 squared minus half of minus 2. So it's going to be a positive 2. This is going to be a positive 2. So the gradient is positive 2. So I have a gradient and a point, negative 5 over 3. So you can just use that straight line formula, x minus x1. So my gradient is 2x minus of minus 2, and then y minus of minus 5 over 3, y plus 5 over 3, 2x plus 2. Therefore, 2x plus 4, this comes that side is minus 5 over 3, y. So y equals to 2x, 4 minus 5 over 3, minus 5 over 3 is 7 over 3. So this is the equation of that tangent to the function. So now they are saying to us, use the graph to determine values of k for which this function will have real roots. You remember, most of the time they put the k this side, so this time they took it that side. So we must make sure that we manipulate negative k, because that is our y-intercept. Let me just zoom it. So our y-intercept is negative k, it's not k, it's negative k. So it's very important to note that. For this guy to have 3 real roots, I must move him up, but I must not move him 2 up. Because if I move him 2 up, he will end up being like this. And then I have only 1 root. So I must be careful of this distance. I must be careful of this distance, because it must never touch this line. Okay, it must never touch this line. So I must not move him beyond this distance, and this distance is 1 over 3 unit. So if I take this function by 1 over 3 units up, it's going to be like here. It's going to be like this, and then this will be 2 roots. So for me to have 3 roots, it will be anything in between these 2 guys here, because it's going to be 1, 2, and 3. So for me to have 2 roots, I must say that my k, because it must be against this thingy, my k must be greater than 0. I must say negative k must be greater than 0. That's number 1. The y-intercept here, this minus k, must be greater than 0. That means if I am to take the k to the other side and bring the 0 to the other side, it's going to be, because remember in inequalities, if you divide both sides by negative, the sign will change. So my k must be less than 0. The other part is that the minus k, which is the y-intercept, it must be less than 1 over 3. Because if I move this to the upper side by 1 over 3, that means the new turning point here is going to cut here at 1 over 3. So it must be less. This y value here must be less than 1 over 3. Must be less than 1 over 3. Which one am I doing? Yeah, it must be less than 1 over 3. Okay. It must be less than this guy, because I'm making reference to this. So it must not be above, it must be less. It must first be greater than this one, than 0, the minus k, which is the y-intercept that I circled. This guy must be greater than 0, but the same guy must be less than 1 over 3 against the new thingy. Therefore, where is the... okay, must be less than that. So divide by negative, so k will be greater than negative 1 over 3, because I divide by negative on both sides. So the final answer in that regard, the final answer in that same regard, the final answer will be k greater than negative 1 over 3, k less than 0. All right, then we are good to go. So this is how you approach such questions. Thank you very much.